All right, now I welcome you once again to another concept on functions. Um, we've already looked at domain of functions. This time we are going to look at the range of a function. When you are asked to find the range of a function, how you are going to go about it. Previously, we already discussed about range, domain, image, when we're doing what relations. We started with relations. We've already looked at it as the same as when we talk of functions. So in this case, we are saying that a range is the set of all images or output of the function. When we say output, we are talking about element of the codomain. And we can also say that the range of a function can be a subset of the codomain. Yes. Or the range can also be the same or equal to the codomain. In that case, when the range is the same as, or when the range is equal to the codomain, we say it is called what? Surjective or onto function. So when we ask you to tell us what a surjective or onto function is, that is when the range of the function is equal to the codomain. There are times that you may have the codomain. All of them will have what corresponding entities of the domain. There are times too you may have some elements of the codomain which may not have what corresponding element of the domain. And when it happens like that, those elements in the codomain that do not have corresponding values of the domain are not range or image. But the moment you realize that all the elements in the codomain belongs to at least one element in the domain, then we say that those elements, the codomain, are the range or the image. Okay. All right. So this one, we are not going to waste time because we've already talked about this in our previous lesson. We are only going to find the range of a given function. When you are given a function to find or determine the range, how you are going to do. In this case, we are going to follow 3 steps. Okay. So we are saying that to find the range of a function, let's say f at x, all that you do is first you let y be what? The f at x, the function given. All right. The y here also represent what? The entire function, and that is what? The codomain. It represents what? The codomain. After that, then our next step is that you make what? X the subject, or you make what? The independent variable the subject. After making the independent variable the subject, which is the x, what you do is you are going to find the values of the y. This y, you are going to find the values of y for which the independent variable is what? Defined. So this one is the same as finding the range of a given function. When you were asked to find the domain, yes, when you were asked to find the domain of a function, we were looking at values of x that make what? The function or the y what? Defined. But this time, because we are making x the subject, we are going to look out for values of the y that makes what? The x what? Defined. All right, good. So in that case, we normally say that the range of a function is just what? The domain of the inverse of the given function. That is how to find the range. So we'll not waste time. Let's look at the following examples and see how we can find the range. So I'll start with my first example. And we are going to follow the 3 steps given. So for my first example, we have, that's one, we have f at x is equal to 3x plus 2. Good. So we are going to follow the steps. In the first place, we are saying that we should let y be what? This function, which is what? F at x. It means we shall replace f at x by what? Y. In this case, our new equation becomes y is equal to 3x plus 2. So that's the first step. What does the second step say? The second step says that after letting y be equal to the function in the first step, we should make x the subject. So it means that we are going to solve for x in terms of what? Y. Yes, we are going to solve for x in terms of y. If that's the case, if I want to make x the subject, so this is the normal way we can group like terms. So what I will do is that I can decide to write my y, then transpose these two here, making negative, and maintain this 3x. All right, good. Now what I will just do is that I will just write 3x is equal to y minus 2. I haven't done anything. I've only changed their position. Okay, I haven't changed any sign, only the position, and it means the same. Once we are making x the subject, then I can divide both sides by what? 3. In that case, my x is equal to 1/3 open bracket y minus 2. Good. Now, this is what we have. So to find the range, we are saying that now we are done with the second step. What does the third step say? The third step also says we should find the values of y for which x is defined. So what this means is that the new equation we have gotten, we have made x the subject, then we are going to find values of this y that will make the function defined. Now looking at this, you realize that you can plug in all real numbers and so x will be defined. If that is the case, then we can send our mind back to what we did in the domain. In the domain, we looked at polynomial functions, we looked at radical, rational functions, and all that. Looking at this example here, since we are seeing that every row number we put in a place with a y, x is going to be defined, then we can say that this is a polynomial function. Yes, good. So if that is the case, if all real numbers, every number, because usually like can test, if you put -2 here, -1, if you put 0 here, if you put +5, whatever number you put here, x will be defined. Then we can write our range is giving us what? Because we are finding values of y. In the domain, we were finding what? Values of x. That's why we were saying x is such that. But this time, when you are finding the range of a function, that means you are going to find the values of y that makes what? X defined. So if I'm finding values of x, then I can say that y is such that y is a member of all set of real numbers. Good. Because we are saying that every real number can satisfy or make the x defined. So this is how we can find our range. Now let's continue with example 2. Now for the example 2, we are given what? A rational function. It is in a fraction form, so it's a rational function. So we are going to determine the range of this function, and as you know, our first step is to let g, so let y be equal to g at x. Good. Now we can write the equation as y is equal to 2x minus 3, all divided by 3x plus 4. In this case, we are going to make x the subject. How do we make x the subject? Looking at this, you see here, we can, because this is a rational function, you can find the LCM. What is the LCM? The LCM becomes the entire what denominator, because this is the fraction part. Then we can multiply through by that. If we multiply through by that, we know that here y is divided by what? 1. Okay, so if we are multiplying through by the LCM, then it means that we're going to multiply 1 by all this and multiply everything here by y. So I'm then going to have my y and then multiplying what? The expression 3x plus 4, which is equal to 1 multiplying this gives me the same expression. Once I have it this way, I can just open the bracket. So if I'm opening the bracket, then I have 3xy plus 4y is equal to 2x minus 3. All right, good. Because we are making x the subject, I can decide to maintain this here, 4y, then bring this, I will transpose this negative 3 here, which will give me a positive 3 is equal to, then I'll maintain 2x, and then I'll transpose this here, giving me negative 3xy. Good. Since I'm making x the subject, I have 2 of the x's here. So I will just maintain everything here. Then just factor x out. Yes. If I factor x out, then here is left with 2. And here is left with what? 3y. Once I have this, I can divide both sides by what? 2 minus 3y. Yes. So we know that this one goes. I have my x. Therefore, my x will be equal to what? 4y plus 3, all divided by 2 minus 3y. So this is what we have. Okay, so we are going to determine the range. And in finding the range, we are saying that the test step is saying that after making s the subject, you are going to find the values of y for which this x is defined. So looking at this one too, let's send our mind back to what we did in the domain. Remember when we're doing rational function, when you have such example to find the values of x for which the function is defined, realize that the only way the function can be defined in such case was to just this every value except what here the denominator being what 0. It means that every number can satisfy or make the x defined except when the denominator is not what 0. Then it can be that. If that is the case, then we can apply that the same idea here. Okay, we are finding value. So the only way s can be defined is when the denominator is not equal to 0. All right, so that is where when 2 minus 3y is not equal to what? 0. Okay, good. So we can solve this one and know the actual value. Okay, if that is the case, then I can maintain 3y and then send my 2 here, divide both sides by negative 3 and negative 3. My y then is what? Shouldn't be equal to 2 on 3. Good. So this means that to find the range of this, every element or every what real number can make S defined except what 2 on 3. Therefore, my range is giving us y is such that y belongs to all set of what real numbers. Y shouldn't be what 2 on 3. Someone can also decide to write it this way. My y is such that y belongs to all set of real numbers except y is equal to 2 on 3. So any of the two, you can write any of them when you're asked to find the domain. All right, so this is our second example. Now let's quickly look at our third example and the fourth example. All right, so let's look at the third example. So for this one, we are applying the same methods here. So in the first place, we shall let let's let our y equals h at x. Therefore, our new equation becomes y is equal to x squared minus 1. We are going to make x the subject. Then I can write this as x squared is equal to y plus 1. What I did was that I only transposed this one here, which will make positive plus, and this one maintain it, but I just change their position and it makes the same thing. It means the same. Good. So once we have it like this, we are making s the subject. So what do? I would only take square root of both sides because I have square here, okay, which is y plus 1, so that the square root will affect the square here. Then I have my x to be what? Square root of y plus 1. Good. So how do we find the range of this, the values of y for which this x is undefined? The only way we can do that is that this one too, you remember what we did in the domain when it has a radical function. We are saying that the only way it can be defined is when whatever is here is what greater or equal to 0. So we can do that. Okay, y plus 1 should be greater or equal to 0. That's the only way x can be what defined. If that's the case, then my y should be greater or equal to -1. So it means that all real numbers can satisfy this. Okay, or apart from this, every element which is greater or equal to -1 can satisfy this. Other than that, no value at all can satisfy again. That's what we are saying. So the only values that can satisfy x or make x defined is what? Numbers greater or equal to -1. Then we can write our range. We've already talked about all these things. We use the number line to test. You remember when we're doing the domain? Yes, we've done all these things. So this one just continuation of what we did in the domain. Okay, then our range becomes what? Y is such that y belongs to all set of real numbers. Y should be greater or equal to -1, and that becomes what? Our range. Okay, now let's look at the last question, which is question 4. So for the question 4, we can proceed and write, we should let our y be what? Square root 4 minus x squared. Because it has a radical sign, all that we do is what? We only square both sides. So we can square both sides. Like this. so that the square will clear this. Then we have y is equal to y squared is equal to 4 minus x um, squared. Great. Now what I can do is that I can bring x here. So I'm just grouping like terms. All right, I can bring x here squared and maintain 4, then send y here, which will give me y squared. Once you realize that this is what we have, then we can just what, take square roots of both sides. Good. So that this one crosses out, then we have our x is equal to what, square root of 4 minus y squared. So we have similar example here. This one is also under what, radical sign. If that is the case, how do we make, or what are the values of y that make what, x defined? The only way this can be defined is when 4 minus y squared is greater or equal to 0. Okay, now since we have this, you remember we have solved similar examples, a lot of examples on this in the domain. So this one, we will not waste time. We can rewrite it as 2 squared minus y squared greater or equal to 0. Then I can use difference of 2 squares. So 2 minus y, 2 plus y. Then we can have this here. Good. If that is the case, I can solve this separately. 0 or 2 plus y greater or equal to 0. If that is the case, then here I can write this as negative y, negative 2. Just divide both sides by 1, 1. Then I'll have this. The sign has to change. As I said, we've already done this similar examples when we're doing domain. Okay, so or here too we can just write y is greater than or equal to what, negative 2. So these are the two solutions we have. Great. Now once we realize that we have these values, we are looking at values that are less or equal to 0 and values that are greater or equal to negative 2. So as we did in the domain, I told you that whenever you have the values, you need to test. And in doing that, we use the number line. So please, if you have forgotten, then you have to go back to what we did in the domain when we're doing a domain of radical functions. We use number line to test. Okay, so in this case, if you try to test, that means if you find values that are less or equal to 2 and substitute here, is it going to be defined? So if I pick let's say 1, if I put 1 here, is it going to be defined? Yes, 1 is going to be defined. If I pick 0 here, is it going to be defined? Yes, it's going to be what? Defined. Yes. What about if I pick, so here we are also talking about numbers that are what? Greater or equal to negative 2. So what about if I pick negative 2 and put it here? Yes, that one is also going to be defined. What about if I pick negative 1 and substitute? It's also going to define. So you realize that both conditions or solutions can what, make x defined. If that's the case, then we can just write our range as range is giving us y is such that y belongs to all set of raw numbers negative 2 less or equal to y less or equal to 2, and that gives us the range. All right, good. We can, this one too, you can also decide to write the interval notation for this one, but we've done all these things in the domain, so you don't need to waste my time. So this is all about the range of a function. Okay, when you are asked to find the range, there are a lot of examples that I will urge each and every one to solve more examples. Now we end here and continue in our next video. In our next video, we are going to look at inverse of a function. Inverse of a function. I'm your facilitator, Ivan Sukai. The name of the channel is Mazris TV. Don't forget to subscribe, like, and share the video. So see you in our next video. Bye bye.